Good afternoon, good evening, good morning, whichever the case may be. We're working on 223 today, equations of lines in a situation. So this is going to go along with the 222 lesson about the tricycle race. During this chapter, you have found linear equations using several different strategies and starting from many different types of information. Today, you're going to apply what you know about writing linear equations to solve a complicated puzzle. Who among you will win the big race? So today is the finale. We're going to look at a series of cards instead of doing it in groups that describe the travel of, I believe, 6 different people in the race. We've got the Heat 1 and 2 winners, Leslie and Elizabeth. Unfortunately, Mark, the winner of Heat 3, is absent from school and will not be participating. Your task. So as a class, we're going to draw a graph on graph paper showing all of the racers' progress over time. We're going to talk about independent and dependent variables, write an equation for each participant, and figure out who will win the race. All right, so let's start. If you're looking either at your physical copies or the digital copies, you will see this page, which are the 6 racers. It's supposed to be 4 people in the group, so you're welcome to name yourselves if you would like. I think I'm probably going to go with like A, B, C, and D. Something very creative along those lines because us math teachers were very creative. Let's just start with let's say A. Oh, never mind. We'll use A because it's on the card. You ride your tricycle 3 meters every 2 seconds and pass rider B 10 seconds after the race begins. The race is 25 meters long. So rider A, what we know so far is you ride your tricycle 3 meters every 2 seconds. We don't have any information about this person having any sort of head start, so we will start at the origin. Our independent variable, if it is available, is always time. And in this case, it's time in seconds. We can call it the independent variable. We can also call it the control variable, depending on whether you're in science class, math class, or who your teacher or professor are. So person A is going to start at 0, 0, and they are going to go every 2 seconds, 3 meters. So I'm going to go up 3 meters over 2 seconds. And the reason that works is because we're going to put distance from start. We're going to switch pens. Distance from start. And we're going to make sure that we put that is in meters, the same way that we put that time was in seconds. And we're going to go up 3 over 2, up 3 over 2. Do a few so that when you use your ruler, you can be sure that you're lined up and you're not missing, missing a third or a fourth point, and all of a sudden your angle is off. So here we go. That's about right. So that is going to be person A. And we're also going to need an equation for person A. If they're going through the origin, they've got an intercept of 0. And if they're going up 3 over 2, we would say that this person is y equals up 3 over 2, 3 halves in lowest terms, x. And then there's plus 0. I mean, hypothetically, there's a plus 0, but we don't write it. So person A is y equals 3 halves x. All right, person B. You get the same head start as Elizabeth and ride 1 meter every 2 seconds. So we would need to look back at yesterday's or 222 and see that Elizabeth, let's see, Elizabeth is starting at 10 meters. So I gotta switch colors. Elizabeth, we'll put Elizabeth at 10 meters and 1 meter every 2 seconds. So up 1 over 2 seconds, up 1 over 2 seconds, up 1 over 2 seconds. And we would keep going and then put our ruler on. And I actually stood up so that I'm looking straight down at this so that I can be as accurate as possible. And that one's going to be Elizabeth. Nope, that's not Elizabeth. That's B. And that one is y equals up 1 over 2 is going to be 1/2. Sorry, I won't use this pen again. Y equals 1/2 x plus 10. That sound is horrid. Throw that pen away. Gone. All right, C. You ride half as fast as Leslie, but get a 4 meter head start. So Leslie, in this case, if you look at your card, says she's going 2 meters per second. So we are going to have person C only going 1 meter per second. and person C got a 4-meter head start. So on that person, we're going to go up to 4 and up 1 meter every 1 second, a nice 1-to-1 ratio. Can't go wrong with that. And I'm going to look straight down on it so that it looks like I'm lined up nicely there. And that one is going to be person C. I'll just pull that down a little bit. So that 1-to-1 ratio is going to be y equals 1x, or just x. And they had a head start of 4 plus 4. Person D, you get a 1-meter head start and catch up to Elizabeth in 4 seconds. Now, Elizabeth's not on there yet, so I'm going to skip down and do Elizabeth's. Elizabeth is 11 meters into the race after 4 seconds, but only 13 meters in after 12 seconds. Her tricycle is slow because she has a flat tire. So if you missed that, I'm skipping person D because hers is based on Elizabeth's. Elizabeth is 11 meters into the race after 4 seconds. So Elizabeth, I'm going to go over to 4 and go up to 11. Let's see, 4, 11. And then I'm also going to go 13 meters after 12 seconds here. And then I've got to figure out sort of her slope. You're going up 2 over 1, 2, 3, 4, 5, 6, 7, 8. That would be the same as up 1 over 4 or down 1, left 4. That's her 10, up 1 over 4. So I've got Elizabeth's, and I'm going to have to base person D off of Elizabeth's. So this is Elizabeth. And Elizabeth is y equals up 1 over 4 is going to be a slope of 1/4 x plus, and we can see that her y-intercept is 10, and that's where we got the 10 for person B. You might have actually, if you were doing this on your own, had to wait to do person B until you had done Elizabeth's first in order to know that she had an intercept of 10, but I already knew she had an intercept of 10. So you probably would have had to have done person A, then Elizabeth, then B, then C, and now I'm working on D, and I would have already known Elizabeth's speed and her intercept. So going back to person D, you get a 1-meter head start and catch up to Elizabeth in 4 seconds. So a 1-meter head start would mean that you were here at 1, and then let's see, you would meet up after 4 seconds with Elizabeth, who is this red line on mine. So you're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 4. So I could do that again. I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1, 2, 3, 4. I could also do up 5 over 2. 1, 2, 3, 4, 5, 1, 2. And I could do it down here. 1, 2, 3, 4, 5, 1, 2. And that would give us the data for person D. And they line up nicely, which is always a good thing. So there's person D, and if I just slide that down a little bit, person D is going to be y equals up 5 over 2 would be 5/2 x, with only a 1-meter head start would be plus 1. And last but not least is Leslie. And Leslie rides 2 meters per second and starts 2 seconds after the race starts. So she actually has gone 0 meters 2 seconds into the race. So she's here at 2 seconds and has covered 0 meters. And then she's going to go 2 meters per second. So you're going to go up 2 over 1, up 2 over 1, up 2 over 1, up, and keep up that pace. If we were to keep up that pace, we'll have to look at this sort of backwards because we still need Leslie's y-intercept. All I did was label that as Leslie. We still need Leslie's y-intercept. And in order to get Leslie's y-intercept, we'd have to come down 2 over 1, down 2 over 1, and we would get that her y-intercept is at 0, -4. So when we're writing Leslie's equation, she's going to be y equals, she was up 2 over 1, so that's a slope of 2x with an intercept of -4 minus 4. All right, so now we've gone through all of them, and what we would do is we would go back to the first page. We would have finished with our graph, which we want to keep a reference available. We would have finished with our cards, and we'd want to go back to the cover page. It said, Use your results from the big race finals to answer the following questions. You may answer the questions in any order, but be sure to justify the response. Who won the finals? Who got to the winning distance first? Now, remember, the distance for this race was 20 meters. And that came from the previous lesson. So if we go here to 20, we would want to say who got to 20 first, and it was that line for person D. So person D is the winner of the race. Who won the finals? Whoever rider D was. Who came in last place? Last place would be who got to the 20 meter mark last. And on our graph, Elizabeth hasn't even gotten there yet. We can go through and say D came in first, then Leslie, then person A, then person C, then person B. And somewhere way over here, Elizabeth with the broken tricycle is going to come in last. So last place was Elizabeth. Which rider or riders other than the winner were in first place for a while? So if you start over here, we had a couple people that were had a pretty big head start. We also had somebody else in first place after the race started for a little while, which was this lightest line, line B. So the person who was actually in first place once the race started for just a little bit was rider B. For approximately how long was this rider or riders in first place? So if we look here, it looks like, I don't know, a little over 4 seconds, maybe 4.5 seconds before person D caught up. So maybe we could say about 4.5 seconds. How many seconds did it take to win the race? So we would want to look at rider D, and we would want to look at how long it took them to get to 20 meters. And it looks like it's about 7.5 maybe for the green one. I'm not sure. I'm going to say my graph looks like it's about 7.5 seconds. However, that conflicts with my other one. How many seconds did it take to win the race? So I'm going to double check that one after the video. For now, I'm going to say that my graph says it took about 7.5 seconds. How fast was rider D traveling? Rider D was going up 1, 2, 3, 4, 5 over 2. Up 5 over 2 would be about 2.5, somewhere right around 2.5 meters per second. 5 halves was their slope, so 2.5. So about 2.5 meters per second. And how fast was Elizabeth traveling? Poor Elizabeth. Elizabeth was going up 1 over 4. She was only going 1/4 of a meter per second. So she would have been 0.25 meters per second. All right, and we've got our graph, we've got our page 1, and then there is one more page after that with just a little bit of a wrap up. It said, at one point in the race, 4 different participants were the same distance from the starting line. Who were they and when did this happen? So in this one, we said that there were 4 people all in the same place, 4 lines that were crossing all at the same time. And that happened right here. After 8 seconds, we had Leslie and riders A, C, and Elizabeth all in the same place at the same time. So we could say rider A, rider C, Elizabeth, and Leslie all in the same place, 8 seconds into the race, 12 meters into the race. What would the graph look like if one of the riders fell off their tricycle? Well, they would continue to have time pass, but they would not continue to move. So all of a sudden, they would be a horizontal line. Now,